Okay, this is section 4.4 on trig functions for any angle. So in this section, we're going to look at how we can define trig functions on the coordinate plane a little bit differently than with a right triangle. So if I look at this picture here, I have an angle drawn on the coordinate plane. The initial side is on the positive x-axis, and the terminal side can be anywhere on the coordinate plane. This one just happens to land in quadrant 2. Okay, so the terminal side of that angle is going to represent r, kind of like the radius in our unit circle. And then the x and y ordered pair are where the terminal side would land on an ordered pair somewhere on our coordinate plane. The x represents how far left or right it went, and the y represents how far up or down that point went as well. So you can see the relationship between these 6 trig functions. Sine of the angle is going to be the y divided by the r. Cosine is x divided by r. Tangent is y divided by x. And then we have the 3 reciprocals, which cosecant is the reciprocal of sine, so that's going to equal r divided by y. Secant is the reciprocal of cosine, so that's r divided by x. And then cotangent is the reciprocal of tangent, so x divided by y. Okay, if you remember when we drew the unit circle in section 2, we labeled or identified what trig functions were positive in each quadrant. So if you remember in quadrant 1, all trig functions were positive, so we put an A out to the side. In quadrant 2, only sine was positive, so we put an S out to the side. In quadrant 3, only tangent was positive, so we put a T. And then in quadrant 4, only cosine is positive, so we put a C. So this just helps me remember what is positive in each quadrant. I memorize ASTC, or the phrase, all students take calculus. You can come up with your own phrase if you want to. Just something to help you know what should be positive in each quadrant. They're going to give us problems in this section and in other sections where we may have to draw and label, find different trig values, and this is just a good reference to be able to check and see if you have the signs of your answers correct, knowing what's positive in each quadrant. Okay, so we're going to look at reference angles. If I have an angle that lands in quadrant 1, I generally will know the trig values for quadrant 1. That's going to be 0, 30 degrees, 45, 60, and 90 degrees. We should have those memorized for sine, cosine, and tangent. It's just when it falls in other locations on the coordinate plane that we may struggle or may not be able to memorize those values. So that's why we use reference angles. So for example, if I have an angle that falls in quadrant 2, this is going to be an obtuse angle bigger than 90 degrees. I may not have this angle memorized. So what I can do then is look at the angle that falls from the terminal side down to the x-axis. This is called a reference angle. It's always going to be an acute angle to the x-axis. So if I want to find the value of this acute angle to the x-axis, then I can take the measure of the angle that I was given and subtract it from either pi or 180, depending if the angle that they give me was in radians or degrees. So in quadrant 2, we're going to take our angle that was given and take it away from pi or 180. If I have an angle that falls in quadrant 3, this is again an obtuse angle that's going to be bigger than 180 degrees, but not quite 270. So again, the reference angle is going to be to the x-axis. It's an acute angle. So to find this acute angle, we're going to take our angle and then take away 180 degrees or take away pi radians from it. Okay, and that will give us again an acute angle to the x-axis. So then when my angle falls in quadrant 4, this is an obtuse angle bigger than 270 but not quite 360. We want the angle from our terminal side to the x-axis. Okay, so to find this angle, we're going to take our angle away from 360 degrees or away from 2 pi, depending if it's radians or degrees. Okay, so let's look at all of these together on the coordinate plane. So in quadrant 1, no problem, we should know those values. In quadrant 2, we're going to take our angle away from pi or 180. In quadrant 3, we're going to take away pi or 180 from our angle. And then in quadrant 4, we're going to take our angle away from 360 or 2 pi. So you notice the reference angles are always going to be acute angles to the x-axis. So somehow it relates to 180 degrees or it relates to 360 degrees. Okay, so always to the x-axis.